Good day, my name is Richard and a warm welcome to Tutoring with Richard, where we cover the South African school syllabus and native topics. Today we're going to cover strength of materials in 6. The topic of this tutorial is deflection of beams. Let's get straight into it. Okay, now we have a drawing of a beam. It is a channel and a rectangular section. Now, Y goes through the middle, and Y. Now, a dotted Y goes through Y, Y. The middle of the channel. Near the middle of this is X, that's the main part, and XX is the center, and XX is the center of your beam, of your Okay, now we need our values. So here is our base. Now, from our base to X is Y1. From this to here is H2. H1 is from here, that's H1. Sorry, this is Y bar. That's Y bar. Y2 is from the base till the middle of that. That's Y2. Y1 is from the base to Y, and the length from there to the base, the length down, so the whole length of our rectangular section, is 260 millimeters. Now, because this is a technical drawing, you don't have to write millimeters. It's already assumed that it will be in millimeters. So this is, and over here, between here and here, is 60. Okay, I've got every measurement we're going to need. Every measurement that we need. Now, our channel is going like this. It's going 180 by 70 by 22 kg per meter. Now, with this tells you which part of your table to look at. So this is what you would use it's called your hot rolled steel tables, because this is what they term hot rolled steel. So in here, in your book, and in the exam, you will get a book of tables. They look something like this. You will get a book of tables. It looks something like this. And they have channels, they have H sections, parallel flange, I sections, parallel flange, I sections, taper flange, and H sections piles. But right now we are looking at channels. So they will always tell you if it's a channel, an I-beam, an H-beam, or whatever it is. And they will give these measurements here to tell you which part of it to look at on your table. So, with our table, we are going 180 by 70. So, R, H, and B do not matter. T1 matters. T1 is what you put down on your right hand side. These are your values of your right hand side. And then A is your area. So your area of this particular hot rolled beam is 2,797 times 10 to the minus 3. Now they'll always say 10 to the minus 3 or 10 to the minus 6, depending on what you're looking at on a table. But that is your standard measurement. It's all in millimeters. Okay, your next one, AY is important. AY is 19,2 millimeters. So keep that in mind. So this will be 19.2 millimeters. Now what we need to do is say it's about, on the table it says about the XX axis. Now we'll need I, only IX. We'll only need IX. We won't need RY. We'll only need IX, and that is 13,54 times 10 to the minus 6. Okay? But I'm going to put IY as well, just in case I might need it. So IY equals 1,135 times 10 to the minus 6. Okay. Now that we have our values from our table,
don't show the book. Don't show the book.
It's not showing.
Just showing the book there. Put the book down on the table.
Okay. Put the book down on the table. And then I'll restate what I'm going to say.
Remember copyright.
Yeah. Okay. Once you have your values for your table, which are all here, all your values for your table are here. These are the values that are most important. Your T1, your area, your AY, your IX, and your IY. These are all very important values. So, they all indicate what's on the formula, on the formulas that we're going to be using. So, our first formula is Y bar AT, area total, equals area 1, Y1, plus area 2, Y2. Okay, in this case, what we are going to be doing is, in this particular case, we will be looking for Y bar. So, we can have area total, which won't be hard to get. We'll have area 1 and area 2. Now, area 1 is your channel, and area 2 is your rectangular section. So, now how do we work out an area for the rectangular section? Because we already have the area for our channel. So how do we work out the area for the rectangular section? Well, what you do is, you say 260, 0.26 times 0.06. So, how that'll work, now let's put it into our formula. Right, so, y bar, bracket, open bracket. Now, we have 2,797 times 10 to the minus 3 plus bracket 0.26 times 0.06, and that is in a bracket. We're only working out, as we go through this, we're only working out sections of our formula. We're not working it all out at one go. Work it out in sections and then bring the sections together. So, now this will be, let's put it in our calculator, and it'll be something our calculators can handle. So, bracket 2,797 times 10 to the minus 3 plus bracket 0.26 times 0.06 bracket equals. Now this is our first answer, so this will be y bar 0, 0, 1, 8, 3, 9, 7. Right, that's our first answer. Now we can get rid of this, and we know that y bar is the first thing in our formula. So, next is area 1 times y1. So what we need is from the base to the middle of this channel. That's how high, that's that measurement we need. Now we know that 260 is involved with that measurement. So what's left is AY. That's what's left. AY is left over to make it A1. So Y1 is equal to 0.26 plus 19.2 times 10 to the minus 3. That is Y1. If you do it like this, now always do everything in sections. So we have Y1, now we can have A1, which is not hard to find, which we already have. So we have A1, A1 is 2,797 times 10 to the minus 3 multiplied by bracket 0.26 plus 19.2 times 10 to the minus 3. Now what we do is we put them all together. So 2,797 times 10 to the minus 3 times bracket 0.26 plus 19.2 times 10 to the minus 3 bracket. Okay, now our first part. So A1, y1 is equal to 7,809 times 10 to the minus 4. So now we need to work out A2, Y2. So A2 is really simple. A2 is simple, so we go, now A2 is 0,26 times 0,06 times Y2. Y2 is exactly half of your rectangular section. So 260, so this is times 260 divided by 2. So what we have essentially is 0,26 times 0,06 times 130 times 10 to the minus 3. And this is also times 10 to the minus 3, but let's put this in simpler terms. I'll put this in simpler terms. So 0,26 divided by 2 is equal to 0,13. That makes it simpler. So let's put them together. A2, Y2. Let's put it all on the right hand side so that we know and we can put it all together now. So first thing we're going to do is open bracket 0,26 times 0,06 open bracket times 0,13, and that gives us an answer of 2,028 times 10 to the minus 3. Now, what we're going to do is put all these together into one big sum. Now, I'd like to point out that this is much simpler doing it this way and doing each part of the sum separately. And doing each part of it separately is much simpler than trying to do it all at once. Your calculator cannot handle that amount of numbers. No matter how sophisticated your calculator is, you will never get it in one go. So you have to break it up into bits. So we have y bar 0,018397 equals 7,809 times 10 to the minus 4 plus 2,028 times 10 to the minus 3. Now equals, now y bar 0,018397 equals, let's add these two together. That's 7,809 times 10 to the minus 4 plus 2,028 times 10 to the minus 3 equals. It is 2,809 times 10 to the minus 3. Okay, So now all we need to do is divide y bar by this number here. And then we divide on the other side. So 0,018,397 0,018,397. That cancels with that, and we are left with y bar. Y bar. Now these will be unimportant after the sum, so I'm just going to erase them for now, but always keep them in your book. Always keep the answers in your book. You may need to refer to them later. So now y bar by itself is equal to 2,8089 times 10 to the minus 3 divided by 0,018397. Equals 152,68 times 10 to the minus 3. Right. 10 to the minus 3 is indicative of millimeters. So how you can write this now is you're looking for y bar, so you can say 152,68 millimeters if you want it. So y bar is 152,68 times 10 to the minus 3, because there's more calculations coming for this. So, next part of the question. We've got to take, the question is that we have to take the moment of area about both axes. So, the moment of inertia about both axes. So, how we do that is we take y bar. Now, the next formula goes like this. The next formula is like this. It goes H1 is equal to Y1 minus Y bar, and H2 is equal to Y bar minus Y2. That is our standard formula for this. So we need H1 and H2 for the next formula. So let's work them out. So H1. So now what we have is Y1, which is this whole thing here, up until the middle, from the base up until the middle of the channel. And then we have Y bar. So it's Y1 minus Y bar. So Y1, we know that Y1, so our sum would look like this. Now we can do all this in millimeters. So take the 260 as it stands, take the Y as it stands, take the 60 as it stands. So what we do is say 260 plus 19,2 minus Y bar, which is 152,68, which equals 260 plus 19,2 in a bracket minus 152,68 equals H1 is equal to 126,52. millimeters. Now H1, now H2 is equal to Y bar, which is 152,68 minus Y2. Now Y2 is 130 because it is exactly half of 260. So 152,68 minus 130 gives us H2. H2 is equal to 22,68. H1 is equal to 126,52. 22,68 millimeters. That'll be important. That will be important for the next sum. So, how we're going to work this is for the x-axis. For the x-axis, we will need this formula. The formula works thus. I x equals I y plus A1 H1 squared plus IX plus A2 H2 squared. Okay. Now IX, the moment of inertia for IX is this part here. It's on the same axis as IY. It's on the same axes. So to work that out, it will be now to work out that will be dB cubed over 12. In this particular case, for a rectangular section, in this case, it'll be dB cubed over 12 equals IX in this particular case. So, now what we're going to do is put everything in our formula. So, let's do it by parts. IY plus A1 plus H1. So we have H1, we have IY, so we have 1,135 times 10 to the minus 6 plus A1, which is 2,797 times 10 to the minus 3. Now this is going in a bracket, multiplied by H1, which is 0,12652 squared. Now make sure that only H1 is squared, not the outside of the bracket. Make sure that only H1 is squared. So 1,135 times 10 to the minus 6 plus bracket 797 times 10 to the minus 3 times 0, 1, 2, 6, 5, 2 squared. Okay, now we have equals 4,5907 times 10 to the minus 5. So that's the first section. So I y a1 h1 plus I1 h1. So it equals 4,5907 times 10 to the minus 5. Right, next part of the sum. Now, Ix plus A2 H2 squared. Alright, so now what we're going to do is say 0,0.6 times 0,26 cubed over 12 plus A2, which is 0,06 times 0,26 multiplied by, this is all in a bracket, multiplied by H2, which is 22,68 squared. Alright, so Ix plus A2 H2. Now we'll get our answer to the question. Now 0,06 times 0,26 times 10 to the 3 divided by 12 plus bracket, open bracket, 0,06 times 0,26 close bracket times 22,68 squared close bracket. Okay. We are left with 9,59 times 10 to the minus 5. That is what we're left with. So, our first, now what we do is we put it all together. Ix is equal to 4,5907 times 10 to the minus 5 plus 9,59 times 10 to the minus 5. All of that will equal 4,5907 times 10 to the minus 5 plus 9,59 times 10 to the minus 5. And we are left with 141,807 times 10 to the minus 6 meters to the 4th power in this case.
Explain that a 4th power is a moment of area, and also explain to them that the reason why you break up the sums into smaller parts is that there's less likelihood of you making errors. So you say that it's the 4th part, and then in closing you say, one of the things I'd like to bring to your attention is that maybe I didn't make it clear in the beginning, is that you break the sums up into smaller parts so that the likelihood of you making errors when you start putting long lines into these calculators is that you're going to make less chance of an error. And then when you do the whole sum together, you bring it all back together again. The other thing which I would suggest that you do is you go dot 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 1, dot 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 2, dot 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 3, so that they can understand that this is part 1 of the sum, this is part 2 of the sum, part 3 of the sum, if you wanted to. It's up to you how you wish to put it. But the main reason for breaking the sum up, and maybe you need to explain yourself, okay? It's not so much that the calculator can't handle it, is that if you break the sum up into smaller parts, it's easier for you to calculate the sums out with less chances of an error. Because the minute you start putting long lines into a calculator, these calculators can handle, they can handle miles.
Wow.
Okay? Right? It's not so much to do with the miles, it's to do with the fact that
the human error.
The possibility of you making a mistake, and that then you get a cascade effect, and that's to avoid the cascade. So you can just think how you want to phrase that, okay?
The reason, I may not have made myself clear in the beginning, but the reason for breaking the sum up into its individual components is that there's less chance of you making an error, because the calculators can handle a lot, but they can't handle all of this. So, and also, if you get a mistake in your calculator, in inputting it in your calculator, it will cascade through the entire sum. So, when I break it up, it is so that I have less chance of making an error. Okay, let's continue. We've got IXX.
M4 means moment of area.
And also, just at the bottom of the sum, when I said m to the power 4, m to the power 4 means moment of area. So that's what we're looking for. We're looking for the moment of area about the XX axis, which is this dotted line here. Okay, so let's erase these two here because we don't need them anymore. And IXX was 141, 807 times 10 to the minus 6. Now let's erase. Now for the IY axis, all that's needed, because the XX axis of the channel and the YY axis of the web are on this YY axis of the section, therefore the H values for the flange and the web are 0, because there is no distance between the centroid and the horizontal plane. So what that states is that there's no distance between them. They are connected. They are connected. You only have H when there's a distance. So on this plane, there is no distance between the two. So H1 and H2 don't exist. So it's the same formula. So I, y, is equal to Ix plus Iy. There is no need for area, there's no need for anything else. It's just that. So, what we're going to do now this formula is always valid, no matter what you do. But for this part, Iyy, it's just Ix plus Iy. Because there's no distance between them when you go on the YY axis. There's absolutely no distance between them. So it's the solid line here. You're measuring the distance of the solid line. That's basically what you're doing on the axes. So Ix is 13,54 plus Iy 13,54 times 10 to the minus 6 plus, now we go dB, which is 0,06 times 0,26 cubed over 12. No, my apologies. It is actually the other way around for this time. It's 0,26 times 0,06 to the power of 3. Because you're dealing with a longer axis now. So the breadth to the dB are switched. That's basically what I've done here, is to switch the dB. So let's get the YY axis. Iyy is equal to 13,54 times 10 to the minus 6 plus, open up, 0,26 times 0,06 to the cubed divided by 12. And we have our number of Iyy is equal to 18,22 times 10 to the minus 6 meters to the fourth power. So Iyy is equal to 18,22 times 10 to the minus 6 meters to the fourth power. Now this is a moment of area. Don't forget that. I hope you found this tutorial helpful. Please give it a like and subscribe. It really helps with the algorithm and to grow the channel. Positive feedback is most welcome. I enjoy reading your comments. Please use the comments section to let me know what topics you'd like me to cover in upcoming videos. Be at peace, be kind to each other, and remember, passing well is achievable. Have a great day. Looking forward to seeing you in the next video.